Hello friends, let us deal with an interesting problem. The problem is stating n moles of an ideal gas moves from state point A to state point B as shown. We need to determine the maximum temperature which it will attain during the process. So if you look at this particular demonstration, so initially the pressure is 2 P naught occupying a volume V naught, and it goes from point A to point B where it have a pressure P naught and volume 2 V naught. We need to determine the maximum temperature which is possible during the process A to B. So if we look at this, we can say that if we calculate at state point A, so if I write temperature at T A, then we can say from equation PV equals nRT, T equals PV by nR. So PV by nR. So temperature at A is 2 P naught V naught by nR. And if we calculate temperature at B, we can say that temperature at B is equal to P naught into 2 V naught. We get 2 P naught V naught upon nR. So we can say that temperature at A is equal to temperature at B. So can we just jump to the conclusion that temperature will remain constant during the process AB? It will be wrong, very wrong. तो ये सही नहीं है. क्यों नहीं है सही? क्योंकि ऑब्वियसली ये आइसोथर्मल प्रोसेस डिपिक्ट नहीं करता है. अगर ये आइसोथर्मल प्रोसेस का इक्वेशन होता तो ग्राफ would be somewhat like this. If it will be a PT graph for an isothermal process, then it will be a process like this. Then maybe it will be correct. We have joined state point A and B using a straight line, and definitely this straight line path is not going to be an isothermal process, and hence we need to think of an alternate solution as to what will happen to calculate the maximum temperature. To start with this, we write the process equation for A to B. So technically, we are writing equation of a straight line AB, which is in PV coordinate. That is in the y-axis, we have pressure P, and on the x-axis, we have volume V. So we can calculate the slope of the graph. So slope of the graph over here turns out to be minus P naught by V naught, and therefore we can write the process equation y equal to mx plus c, and if we use this expression y equals mx plus c, so in y we have pressure P, m is equal to minus P naught by V naught, x is volume V plus c. So now we need to determine this constant c to complete this process equation. If I put the values associated with A, that is 2 P naught for a volume V naught, then we can say 2 P naught is equal to minus P naught by V naught for volume V naught plus C. So over here on solving we obtain C is equal to 3 P naught. So therefore the process equation is taking the form P equals minus P naught by V naught V plus 3 P naught. So this is the process equation for the process AB. I hope this part is clear. First thing that we did was calculate temperature at A, then we calculated temperature at B. It is also evident to us clearly that it is 2 P naught V naught, and this one is again 2 P naught V naught. So temperature at A and B are same, but we need to calculate the maximum temperature, and this is not isothermal process, because isothermal process is depicted by a curve like this. So we can say that the temperature is not going to remain constant as we move from state point A to B. Now over here the problem with this part is that we don't have a temperature term associated with it. तो अपने को temperature का term यहाँ पे लेकर के आना पड़ेगा. मैं एक बात बार बार repeat करता हूँ whenever we are having a classroom program, कि जब भी कोई problem अपने solve कर रहे हैं और problem में एक बात हम लोगों को पता है कि ideal gas है और कहीं problem एक dead end पे आ जाता है कि अब समझ नहीं आ रहा है इसके आगे क्या करें, so we go back to the ideal gas equation. So over here if I go back to the ideal gas equation, that PV equals nRT, then the life gets sorted over here as we can write pressure in terms of volume and temperature. So we can now write pressure as nRT by V, and if I substitute P over here as nRT by V, then we can rewrite this expression as nRT by V is equal to minus P naught by V naught V plus 3 P naught, and hence the expression for temperature turns out to be minus P naught by V naught V squared plus 3 P naught V upon nR. So this is the equation for temperature which we have. तो ये बड़ा एक इम्पोर्टेंट बात है कि जब भी आप कोई भी डेरिवेशन कर रहे हैं, कोई डिडक्शन कर रहे हैं, जहाँ पे आइडियल गैस लिखा हुआ है, तो ऑलवेज कीप दिस इन माइंड that you can always use this expression PV equal to nRT, and whenever out of 100 problems, in 99 problems, whenever you get stuck in the problem, always remember that this is the key to it, that you write PV equal to nRT and you will get a path ahead how to approach the problem. So over here also we get the path ahead from PV equal to nRT. So PV equal to nRT में T का वैल्यू ये आ गया, and we are calculating maximum temperature. For temperature to be maximum, for T to be maximum, we are calculating dt by dV and we will equate it to 0. So if we calculate dt by dV, then we get minus P naught by V naught 2V plus 3 P naught by nR, and this is equated to 0. So over here we get an equation like this. It's यहाँ पे भी nR का term आएगा. So nR is also going to be associated over here. So we'll get an equation like this, and over here on solving we obtain minus P naught 2V by nR V naught is equal to 3 P naught by nR, and we can remove nR, P naught, P naught. So for volume V equal to 3 2V by 3, volume V equal to 3 V naught by 2, we get temperature to be maximum. So for volume V equal to 3 V naught by 2, we will have the maximum temperature possible. So over here, this 3 V naught by 2 is located here, which is midway between these two values. So we will have 3 V naught by 2, which is 1.5 V naught, is between V naught and 2 V naught, and hence the corresponding value of pressure is going to be 3 P naught by 2. But volume associated with 3 P naught by 2, we can calculate the pressure either by putting in this equation, or we can directly see from graph that if this value is 3 V naught by 2, it must also be minus 3 P naught by 2. Now if we solve for temperature using ideal gas equation, we will get the maximum temperature, that is from equation PV equal to nRT. So at pressure equal to 3 P naught by 2 and at volume 3 V naught by 2, we get maximum temperature possible. So maximum temperature possible is equal to 9 P naught V naught upon 4 nR. So this is the maximum temperature which is associated with this particular process. Now additional to this, we have already solved the problem over here. This is the required temperature in the problem. Now if I think in terms of temperature volume graph, so if we think in terms of temperature volume graph, so we can say that temperature at point A and temperature at point B, so at A volume is equal to V naught and at B volume is equal to 2 V naught, and temperature at these 2 points are same. So the starting point of the graph and the ending point of the graph associated with process AB is going to be same, and in between it attained a temperature which is greater than 2 P naught V naught by nR, which is 9 P naught V naught by 4 nR, that is 2.5 P naught V naught by nR. So we have a maximum temperature over here, and then we can join the curve like this to obtain the curve for temperature volume graph, which is going to take a look like this. So the maximum temperature in this problem is 9 P naught V naught by 4 nR, and this is the graphical representation of the same. So this is how we solve this interesting problem. Again, the key takeaways from the problem is, we begin the problem by writing the PV equation, or the equation of a straight line, and in y-axis we are measuring pressure, in x we are writing volume. So we get the process equation like this. The next thing which we did in this problem is, when we had a deadlock in the problem, we use the process equation for ideal gas PV equal to nRT and substitute the values to write the equation in terms of temperature. And then since the problem is asking maximum temperature, we did the condition for maxima by calculating dt by dv and equating it to 0. So this is how we approach this kind of a problem. Kindly like, share and subscribe the channel to watch more.